So let's get into multiplying by 10. Multiplying by 10. So when I multiply by 10, we know that 5 times 10 means 10 plus 10 plus 10 plus 10 plus 10. It means 5 tens. And we know that 5 tens would be 10, 20, 30, 40, 50 by counting by tens. Now there's a shortcut. What we pick up on is if you multiply by 10, all you really got to do is add a trailing zero. In other words, add a zero to the end. So when I see 25 times 10, since I'm multiplying by 10, all I got to do is stick a zero on the end and say that, well, the answer is 250. That's all the math that's really done when you multiply by 10. Because multiplying by 10 is increasing place value. So it's shifting everything over one place value. So instead of being in the ones place and the tens place, the 2 becomes then the hundreds place, the 5 becomes in the tens place, and there's not anything in the ones place, and we use 0 as a placeholder. Something else to bring out is trailing zeros. These zeros on the end can mean multiplying by 10. So when I see 60, that means 6 tens or 6 times 10. So these are equivalent. These are interchangeable. They mean the same thing. 800, notice how there's 2 trailing zeros. That means 8 times 10 times 10. So that would be equivalent to, it's the same as 800. Those are equivalent. They mean the same thing. 5,000, notice how there's 3 trailing zeros there. 1, 2, 3 trailing zeros. So notice that we have 5 times 10 times 10 times 10. Those are equivalent. Those are interchangeable. And how this works for us is, if I look at this example over here, when I see 60 times 30, what we can do with these trailing zeros is I could change 60 to 6 times 10. I could change 30 to 3 times 10. And remember, multiplication order does not matter, so we're allowed to move things around. So these front numbers, the 6 and 3, I can put them together and then multiply by 10 and multiply by 10. Well, 6 times 3 is going to be 18. And then we're going to be multiplying by 10 and multiplying by 10. But what's easy about multiplying by 10 is all you have to do is add a 0. So 18 times 10 is adding 1 0, and then 8 multiplying by another 10 means add a second 0. So that answer becomes then 1,800, 1,800. So we pick up on as a shortcut, if trailing zeros are involved, all you got to do is multiply the front end numbers and then attach the trailing zeros. So to do this number, since there's trailing zeros involved, just multiply the front numbers together, the 5 times the 3, get the 15, and then stick on the trailing zeros. So since there's 3 trailing zeros, we would have that. So therefore, our answer is going to be 15,000. And that's how we can multiply by 10. So the distributive property is the next thing we want to talk about. The distributive property is when you multiply through addition. So notice how you have this 5, and then inside these parentheses we have addition 7 plus 2. So if there's multiplication on the outside and there's addition on the inside of the parentheses, this is what distributive property is going to look like. And the way distributive property works is we're going to multiply through the addition. So what this means is this 5 on the outside is going to multiply to both addition pieces. So in turn, this turns into 5 times 7 plus then 5 times 2. 5 times 7 is going to be 35. 5 times 2 would be then 10. And therefore, answer turns into 45. Of course, you could also have added 7 plus 2 together and got 9, and 5 times 9 would have been 45, but that's not the distributive property. So there's more than one way to work this problem, but if I'm applying the distributive property, you multiply through the addition. So when I see this problem right here, the distributive property says I'm allowed to multiply through the addition. That's another way to do it. So I could say 3 times 4 plus then 3 times 1. And when I do that math, 3 times 4 turns into a 12. 3 times 1 is a 3. And 12 plus 3 becomes then 15. So that would be another way to do the problem. And that's using the distributive property. You're multiplying through the addition. So the distributive property, there's a number on the outside that multiplies through the addition that is inside the parentheses. So notice right now, this would not be distributive property. That would just be 5 times 23. But what we're allowed to do, though, is we're allowed to change 23 into an addition problem using place value. So the 2 means a 20, and the 3 means just 3 ones. So what I can do in this problem is I can multiply through the parentheses. So the 5 times 2, remember that since there's a trailing 0, I can just go 5 times 2 is 10 and add a trailing 0. That turns into 100. And then we can multiply the 5 times the 3, which is 15. And then if we put that together, that'll give us then 115. So when I do 2 times 135, the distributive property, you have to have addition. So what I'm allowed to do is change the 135 into an addition problem. The 100 is what the 1 means, plus the 3, which means 30. And then we have a 5 ones. So I could change that to 100 plus 30 plus 5. Those are equivalent. But now it's an addition problem, so I can distribute the multiplication through these 3 pieces, multiply it through. 2 times 100, again, 2 times 1 would be 2, and then you have those 2 trailing zeros. That makes a 200. And then we have 2 times 3, which is 6, with 1 trailing 0, makes 60. And then you have the 2 times the 5, which is then the 10. So those 3 pieces now get added together. So 200 plus 60 would be 260, plus 10 more would be then the 270. So that's how distributive property works. So right now I have 3 times 45. That's not distributive property. But again, I could change it to 3 times 40 plus 5. Now I can actually make the math easier. By changing it to this problem, I really don't need much math to make this work. So distribute the 3 through the addition. 3 times 4 is 12. Add the trailing 0 in. And then we're going to add to that the 3 times 5, which is the 15. And then 120 plus 15 would be then 135. So that's how distributive property can start working for us in problems where, you know, I really wouldn't want to add 23 5 times, things like that. So this becomes a better strategy as we move forward.